Good day to everyone. So in the last several videos, we have discussed about the ordinary differential equations and the numerical methods to solve the initial as well as boundary value problems. And we have we discussed several Euler's method and modified Euler's method, which is known as the Xournal method, and Runge-Kutta fourth order method. And if you want to solve the boundary value problems of ordinary differential equations, we have used the finite difference method to solve this ordinary differential equation. Now in this video we are going to start about the partial differential equation. And we will study the numerical solutions to solve the some second order linear partial differential equation. And most of the mathematical models of the physical systems give rise to a system of linear or non-linear partial differential equations with initial as well as boundary value problems. So since the analytical methods are now not always available for solving these kind of problems, we attempt to solve this kind of equations using numerical methods. So if you want to solve this partial differential equations using numerical methods, you have two broad classified methods. One is the finite element method. The finite element method is the one method to solve the partial differential equation. The another method is the finite difference method. So these are the two broad methods which is available to solve the partial differential equation. However, in this unit, we only covering the finite difference method to solve the partial differential equation. Okay. So you know how this partial differential equations will look like and what is the difference between the ordinary and the partial differential equation. So in ordinary differential equation, you have one independent variable and one dependent variable. So the dependent variable, the dependent variable is actually depends only on the only one independent variable. However, if you look into the partial differential equations, the dependent variables will vary with respect to the two different independent variables. And you have also studied some of the analytical methods to solve this partial differential equation in your previous semester mathematical physics classes. So in order to solve this partial differential equations is with the numerical techniques, I am going to consider the second order partial differential equation, which is having the form of general form of a into u xx plus 2 times of b into u xy plus c times of u yy plus d into ux plus e into uy plus fu plus g, which is equal to 0. Here this uxx is nothing but the dou squared u by dou x squared, and uxy, which is equal to dou u divided by dou x into dou y. Similarly, the uyy, which is equal to dou squared u by dou y squared, and ux, which is equal to dou u by dou x. Similarly, dou uy, which is equal to dou u by dou y. So this is what actually this dou squared u by dou x squared is actually conveniently written as a u in subscript having the double x's. This is nothing but the dou squared u by dou x squared. Similarly for the other version. So this is the second order partial differential equation. Here this a, b, c, d, e, f, g are the functions of the x and y, which are actually the real constants. The a, b are the real constants. So suppose if you consider this kind of partial differential equation, the partial differential equations can be classified into three different equations. So one is the elliptical equation. The second one is the parabolic equation. And the final one is the hyperbolic equation. So how this equation, the second order linear differential equation, can be classified with the three different equations is based on the coefficients of this uxx, uxy, and uyy. That means the the values based on the values of A, B, and C. This equation is actually classified into 3 different equations, since the other variables, the other constant D, E, F, and G is not actually contributing to the classification of the partial differential equations, because everything is a lower order term in the considered equation. So suppose if you consider this equation, the general equation, suppose if you consider the value of A, B, C is actually satisfying the 3 different conditions, that is the B squared minus AC, which is equal to 0. So the values of this A, B, C is actually satisfying this condition, then the corresponding partial differential equation is known as the elliptical equation. Otherwise, if the B squared minus AC, which is for elliptical equation, this is actually less than 0, and for parabolic equation, B squared minus 4AC, which is equal to 0, then the corresponding equation is actually known as the parabolic equation. Otherwise, B squared minus AC is greater than 0, then is the hyperbolic equation. The equation is actually come under the classification of hyperbolic equations. So we can also give some simple examples of these 3 different equations, which is one is suppose if you consider the u of t, which is equal to c squared into u xx, that is dou squared u by dou t is equal to some constant, the square of this constant into dou squared u by dou x squared, which is nothing but the one-dimensional heat equation, which is coming under the classification of parabolic equation. So the parabolic equation, suppose if you consider the u of t, which is equal to c squared into u double x, that is the heat equation. So this heat equation is actually coming under the category of the parabolic equation. Suppose if you want to find out the example for this elliptical equation, so u double x plus u double y, which is equal to 0, that is the Laplace equation. You already know this. So the Laplace equation is actually coming under the category of the elliptical equation. And for the hyperbolic equation, I can write the wave equation u of double t, which is equal to c squared into u xx. This is the wave equation. So the spreading of waves is actually described by this equation, which is actually coming under the category of the hyperbolic equation. If you want to quickly check these equations, how this equation is coming under this category, suppose if you consider the parabolic equation, that means ut plus which is equal to c squared of uxx. Suppose if you consider this, you just find out the coefficients of all these variables, so a and b and c. Suppose if you just directly compare this equation to the general equation, you can see that the a is nothing but the c squared here, and so the coefficient of xy and uyy is not available. Therefore, the coefficient of b is 0 as well as c is 0. So that if you substitute these two three ABC values into all these 3 equations, it only satisfies this equation. That means b squared minus 4ac, because which is equal to 0. So that the heat equation is coming under the category of this parabolic equation. Similarly, if you consider the wave equation utt, which is equal to c squared of uxx, and if you collect the coefficients of a, b, and c, the value of a is here is actually c squared, and for b is equal to 0, and for c, and the value of c is -1, because if you take this u of tt in this direction, and if you equate this equation to 0, either the c square will have the negative value, or this value, the u of tt, having the negative value. So I am taking this c is -1, so that if you substitute these three values, a is equal to c squared, b equal to 0, and c is equal to -1 into this any equation, this equation actually having the values of getting the value of c squared, which is greater than 0. So that is it is actually considered with which is under the category of the hyperbolic equation. And finally, if you look into the Laplace equation uxx plus uyy, which is equal to 0. So here the ux is a equal to 1 and b equal to 0. Similarly, c is equal to 1. So again, if you substitute all these values into this equation, then you will get the category of the b squared minus ac is equal to less than -1 you will get. because A and C are 1, so you'll get the negative value here. You'll get the which is negative less than 0, so that the corresponding equation is actually coming under the category of the elliptical equation. Okay, so why we are actually classifying this equation into 3 different categories, or what is the importance of this classification? So this classification is actually governs the number and the types of the conditions that should be prescribed in order that the problem has a unique solution. For example, for the solution of the one-dimensional heat equation, which we have considered here, UTT, which is equal to C squared UXX, we require an initial condition to be prescribed at suppose u of x comma 0, which is equal to some function of x, and similarly the conditions along with the boundary lines x is equal to 0 and x is equal to L. So we have to give the boundaries at these two values, so that we can solve this the heat equation, where this L is the length of the rod which we have considered for the modeling this equation. So L is the length of the rod, so which is actually the boundary conditions are to be prescribed to solve this equation. Similarly, if you consider this one-dimensional wave equation, so which is actually represents the vibration of an elastic string which is having the length of L, and here suppose if you consider the values of u of x comma t, which represents the displacement of the string in the vertical plane. So for this to find out the solution of this equation, we require two initial conditions to be prescribed. So that means that the initial displacement at u of x comma 0, which is actually written as some function, as well as the initial velocity, which also we have need, because that means u of t at x comma 0, that is we have another function. So we require two different initial displacement as well as initial velocity required to calculate to find out the solution of this the wave equation. And the boundary values of this equation is actually at from x is equal to 0 to x is equal to 1. So x is equal to 1. So using this boundary conditions and the initial values, we can actually find out the solution of this wave equation for the hyperbolic equation. And similarly, the solution of this the Laplace equation is required to find out the solution of this Laplace equation. We require the boundary conditions to be prescribed at the curves of the boundaries. So if you know the initial conditions, then the boundary conditions, then we can solve this the elliptical equation with the Laplace equation. Okay, so now I'm going to discuss some of the examples of this partial differential equations, and I'm going to find out classify this partial differential equation with using this which classification, sorry, which equation is coming under the which classification. The first equation I am considering is uxx, which is equal to 6 times of ux plus 3 into uy. So here this is the equation which we are considering. So I can just rearrange this equation as a uxx minus 6u times of ux plus minus 3 into uy, which is equal to 0, and you can compare this equation with the general equation here. Then you can easily match the coefficients. So for this equation, so ux is having the coefficient of 1. That means the a is equal to 1, and b is 0 because it doesn't have any xy term or yy term. So that the b equal to 0 as well as c equal to 0. And if you substitute this equation into this b squared minus ac, which is equal to 0, then so the corresponding given partial differential equation is coming under the type of the parabolic equation, because the b squared minus 4ac equal to 0 is actually coming under the category of the parabolic equation. Okay, so this is parabolic equation. Similarly, the second example is 2 times of uxx plus 3 times of uyy minus u times of x plus 2 times of uy, which is equal to 0. So this is the second example. Here again you can just take the coefficients of xx, xy and yy. So here you have the values of xx and yy. So that means the xx a equal to 2 and b equal to 0, c is equal to 3. So if you substitute all these values into this b squared minus ac value in this equation, then you will get the value of which is equal to minus 6. That means it is actually less than 0. So that the considered equation is the elliptic equation. Okay. So I can also solve one more example, which is u of tt plus 4 times of u tx plus 4 into u of xx plus 2 into u of x plus ut, which is equal to 0. So this is the equation which I have considered. So I can just consider the find the values of coefficients, collecting the coefficients of the ABC. So here you can see that u of tt is nothing but we can just consider this is the u of xx, and 4 times of u of xx is going to be the consider the yy term. That means the dou squared u by dou y squared, and this is taken as the first independent variable. So that the value of a which is equal to 1 and b is equal to, so the value of b is equal to 4 because tx we can take the x and y, and the value of c is also equal to 4. So that I can just substitute these values into my b square minus 4 is the b square minus ac. So the b square value is 16 and a is 1. So you substitute the values, you get the 16 minus 4, which is equal to 12, that is greater than 0. So if the b squared minus ac is greater than 0, then that is actually coming under the category of the hyperbolic equation. So this equation actually is the hyperbolic. Similarly, in this way, whatever the values, whatever the second order partial differential equation is given, so you can easily identify which for which category the corresponding equation is belongs. So just taking this, just finding comparing this the conditions and the coefficients of the corresponding equation. Okay, so with this introduction of the partial differential equations, I stop this video here, and the next video I will explain the finite difference method to solve the partial differential equations. Okay, so if you have any doubts, then you can clarify it in the online class. Okay, thank you.